Here's problem 12. What we're trying to determine is there a slant asymptote or a hole on this graph we have right here. Now again, we always are thinking about slant asymptotes when the top is 1 degree higher than the bottom, and in this case it is. This is of first degree, that's of second degree. So we think maybe there's a slant asymptote. Well, we always want to see, does this top factor? And if we pay attention to this, this is nothing more minus 8. Looks like to me, this looks like an x minus 2 times an x plus 4. Those two binomials will multiply and give us that top. So if I just rewrite the top like this, and the bottom happens to be an x minus 2, this and this are going to cross out, and all you and I really have is the graph y equals x plus 4. This complicated thing is nothing more than the graph of y equals x plus 4. However, we have to be very careful because x can't have the value of 2. That means, what we learned earlier in the year to write is we'd say, hey, but x can't be 2. So when we graph this, we're going to have this nice graph of y equals x plus 4, but at 2, we got to say you can't be this. So there's going to be a hole right here at x being 2. So if we drew this graph, you're basically saying right here is 4 on the y-axis. You have it going up, but right here at 2, you got to say, hey, put a hole right there. You can't quite touch it at 2. There's no solution at 2. So in this type problem, we determine that there is a hole at x being 2. We realize this just simplifies to this, so there's going to be a hole at x being 2. There is no slant asymptote. The line itself is just slanted. So slant, we would just simply say none. There is no slant asymptote, just like there's not a horizontal nor vertical asymptote in this problem. This problem is just a very simple graph of y equals x plus 4, as long as you don't have x being 2. So we have a hole at 2. There you have problem 12. Hope it worked out for you.